All right, so today we're going to talk about two things. We're going to talk about hypotenuse leg, and this is not going to let me write, and Cpctc, which is really fun to say. So hypotenuse leg only deals with right triangles. So before today, the only things you had to prove two triangles were congruent were side, 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 angle, side, angle, or angle, angle, side. Now, again, before today, that's what you had in order. Those were our shortcuts to prove triangles are congruent. Now we're going to add one more, and he's kind of all on his own. This is a very specific case. In order to have a hypotenuse, you have to have a right triangle. So this case can only be used for right triangles, hence the hypotenuse. The only way you can find a hypotenuse is it's across from the right angle. So in order for two triangles to be congruent, if they're right triangles, you could also have a shortcut called hypotenuse leg, where here we have JL is equal to PM, there's hypotenuse, and then leg, just one of the other legs, which this one, JK and NM, are congruent. So yes, these are two congruent triangles by hypotenuse leg. Now I want to warn you, remember we talked about our no-nos. No-nos. If it lets me write. I don't know why it's being angry. We could not do donkey or backwards. Okay, no SSA, no ASS. Or we could not use AAA. Okay, those were our two no-nos. So when you look in here, you might actually see angle, side, side, or side, side, angle. And you might say, oh, nope, that's not enough information. So if you ever see this, just double check that it's not a right triangle, because that's when hypotenuse leg pops up, is when it is angle, side, side. This is an extra one. If it's a right triangle, you could call this hypotenuse leg. All right. So let's try some examples. So the first one, now remember the stuff that we had before. See how UW in this triangle is the same as UW in this triangle? You can mark that with a tick mark just so you see it. So now these two triangles, it looks like they have a hypotenuse in common, UV and XW. So hypotenuse, UV is congruent to XW. And then leg, they have a leg in common. That's that reflexive property. UW is congruent to UW, right? That's that reflexive property. So yes, they are congruent. Let's do our congruence statement. Triangle, how about WVU? WV VU is congruent. And so W goes with U. WVUXW by hypotenuse leg. All right, that is going to bother me, so we're going to erase that real quick. We're going to write a real V. There we go. All right, moving on to the next one. So I don't see anything else I can mark in the picture. There's no reflexive, there's no vertical angles, right? So there's nothing else I can really mark in this picture. So is this enough? Well, for hypotenuse leg, you need a hypotenuse. So here's my right angle. It's not even marked. So we do not have enough information. We have a leg. So what else would we need? Because it does say tell what else you would need to know. What else would we need to prove these two triangles are congruent? Well, we need the hypotenuse. So we would need TR is congruent to RP, PR. And if we had that, then we could say, yes, these are congruent by hypotenuse leg. All right, so hypotenuse leg, again, the only time you can use this is for right triangles. Now, I do want to emphasize you can still use all the other stuff with right triangles as well. So if you had right triangles that looked like this, that is not hypotenuse leg, that is side angle side. So all the stuff that you learned before still applies to right triangles. It's just I'm giving you one extra tool. Okay? Now Cpctc is short, it's the abbreviation, for corresponding parts. So corresponding parts means the parts that go together, like angle S goes with angle Q, side TR goes with side PR. So corresponding parts of congruent triangles, and that's the most important part of this theorem. The triangles have to be congruent, are congruent. So where are we going with this? So let's look back here. You told me these two triangles are congruent by hypotenuse leg. So now, without me having to mark anything, you should be able to tell me that angle V is congruent to angle X, right? Because we know that the triangles are congruent, then we know that their parts are congruent. So once you tell me, hey, these two triangles are congruent, you know everything. You know that VW is equal to UX. You know that angle V is congruent to angle X. So once you prove that the triangles are congruent, you know that all their corresponding parts are congruent. And that's what Cpctc is telling you. Once you've proven triangles are congruent, you can tell me all the parts are congruent. So let's dabble in a proof. So this says given the two triangles are right triangles. So we see that right angle, we see this right angle. All right, right triangles. And UX is congruent to UV. Notice they already put a tick there for you, but if they hadn't, you would go ahead and say UX is congruent to UV. Prove that angle X is congruent to angle V. And this is where Cpctc comes into play. In order to prove that these two angles are congruent, you have to first prove that these two triangles are congruent. So that's what we're going to do. So first one was given. UX is congruent to UV. Again, that was given. So you always start off with your givens usually. And then the next step says UW is congruent to itself. Well, again, what it's trying to say is UW in this triangle is congruent to UW in this triangle. And why? That's that reflexive property. And like I told you when we were learning this, the reflexive property usually comes in these proofs, and that's when it makes sense, because you're telling me that UW over here is the same as UW over here. I know it seems silly to say UW is congruent to UW, but you've got to tell me they have that side in common. All right, so let's look in our picture, because the next step's blank. All right, remember you wanted to prove the two triangles are congruent, so we're going to say triangle, how about X, sorry, how about triangle UXW? How about that? UXW is congruent to triangle. So we did UXW, we're going to do UVW. And why are they congruent? Right? Why are these congruent? Well, they have a hypotenuse and a leg. They're congruent by hypotenuse leg. So this example kind of mixes both of them, right? We're going to use HL and Cpctc. All right, so now we proved that these two triangles are congruent. So if these two triangles are congruent, then yes, angle X has to be congruent to angle V because of Cpctc. So again, you tell me the triangles are congruent, you can prove that their parts are congruent. And that's what Cpctc does. So if you notice, there's some proofs. We're going to get really acquainted with proofs here. But I'll do a few with you. I'll do a few with you first. So let's look at the first one. So it says given GH is congruent to KL, GH gets a tick, KL gets a tick. And given angle G is congruent to angle K. Sometimes you gotta mark some missing stuff here. So angle G is congruent to angle K. That was given. And they give you a lot of stuff here. GI is congruent to KJ. So again, always mark with tick marks. And again, that was given. So we started with a lot of givens. Are these two triangles congruent? Well, yes, they're congruent by side angle side. So remember, when you see side angle side, that's proving two triangles are congruent. So triangle, how about GHI? GHI is congruent to triangle KLJ, KLJ by side angle side. So these are congruent by side angle side. Again, an angle in between two sides. Now that we proved the triangles are congruent, now you know their parts are congruent. So since we know these are two congruent triangles, yes, you can tell me HI is congruent to LJ because of Cpctc. All right, corresponding parts, the ones that go together, of congruent triangles, you just told me they were congruent, are congruent. All right, let's skip down a little bit. Skip down to here. So sometimes parallel lines pop up. So we're going to start with our AB is parallel to DE. That was given. All right. So we know that these lines are parallel lines. And then they also gave me AE bisects BD. So AE is cutting BD in half. AE is cutting BD into two equal pieces. And that's what that word bisects means to you, right? Two equal pieces. Now here it says ABC, angle ABC is congruent to angle EDC. You might say, Ms. Blake, how do we know those are equal? All right, what's my reason? So let's go back to parallel lines. So if you have parallel lines cut by a transversal, alternate interior are equal. So alternate interior angles theorem. All right. Same thing with the other. I lied. Not same thing. So let's look here. Let me get rid of some of this. So that way we can see the picture a little more clear. All right, so we got those. Let's move on. Angle ACB, this angle right here, is congruent to angle DCE. Well, why are those congruent? Because they're vertical angles. All right, we're getting somewhere. Next one says definition of bisect, and we kind of skipped ahead to that before. What does it mean to bisect? It means it cuts into two equal pieces. So AE bisected BD into two equal pieces. So definition of bisect is BC is going to be congruent to CD because of that word bisect. Next step says triangles are congruent. Well, are my triangles congruent? Yes, by angle, side, angle. And then the last step is what you wanted to prove. Here's what you wanted to prove. You wanted to prove AC was congruent to EC. Well, think about it. You just proved the two triangles are congruent. So yes, their parts are congruent. Cpctc. All right, so you're going to finish this up. Remember, vertical angles exist. That reflexive property pops up, hypotenuse leg, and then all the other stuff we've learned. All right, tell me if you have any issues. Again, make sure you're marking your pictures. Bye, guys.